When dealing with a 200 amp breaker feeding a 200 amp fuse disconnect for a 25 horsepower 208 volts 3-phase elevator, determining the correct conductor size is crucial. The motor's full load amperage, or floor, impacts this decision significantly. Before adding the 125% factor for conductor sizing, the motor table indicates an approximate FLA of 75 amps for conductor and overcurrent protection sizing. With time delay fuses at a starting percentage of 175% of the FLA, the fuse size appears to be considerably less than 200 amps, closer to 131.25 amps. The initial consideration for a 200 amp breaker stemmed from the possibility of a larger elevator motor. Given the current setup, the question arises regarding the required conductor size from the panel board to the disconnect while maintaining the 200 amp breaker. The conductor size must align with the breaker's rating to handle the maximum potential current. If the 200 amp breaker remains in place, the conductors must be rated for 200 amps. The overcurrent protection device dictates the conductor size, ensuring they can safely handle the maximum current. Calculating the fuse size for the 25 horsepower motor involves multiplying the FLA by the starting percentage. Therefore, the fuse size equals the FLA multiplied by the starting percentage, which equals 75 amps multiplied by 1.75, which equals 131.25 amps. The NEC mandates specific procedures for conductor sizing, depending on the application and type of load. Motor circuits often require conductors to be rated at least 125% of the motor's full load current, as listed in NEC Table 430.248 for 3-phase alternating current motors. The 200 amp breaker dictates the use of 200 amp rated conductors. However, 130 amp time delay fuses can provide adequate overcurrent protection for the motor. Therefore, even though the motor's FLA is only 75 amps, the 200 amp breaker necessitates 200 amp rated conductors, but 130 amp time delay fuses can still offer sufficient overcurrent protection for the motor itself.